We are here today to learn from our friend and neighbor, Jessica Hellmann. We have some new people here, new Tuesday groupers here today, and I was explaining that our Tuesday group roster of speakers is heavily based on learning from our friends and neighbors, right? People who are members of our community. And it is very special that because we live in a town that is famous and well loved, that our network is very broad, and it's much bigger than you would expect for a town of 3,500 people, or a broader Ely area of about 10,000 people. And so we get to learn today from the executive director of the Institute on the Environment, Jessica Hellmann. And Jessica is also the consortium director of the Midwest Climate Adaptation Science Center, and she is a person of many distinguished titles that I am not going to share all of them with you today, but please know that it is truly an honor that Jessica is a member of our community, and then we get to learn from her today, and we get to ask her anything about climate change, which is a pretty bold offer, and we're really grateful for that. In order to do that and to be able to capture this experience, I do ask that you ask your question into a microphone, and I will help facilitate that. So your patience is appreciated. And please join me in giving Jessica Hellmann a warm welcome.
Good afternoon, everybody. Thank you. All right, well, it's a pleasure to be back with you today. I just want to second Lacey's comment about what an extraordinary place this is. We are all extraordinary. You are all extraordinary. The fact that you're dedicating Tuesday afternoons to big ideas and unknowns and lofty questions and time together, that's part of what makes Ely special. It makes it just as special as the beautiful scenery and the lovely fresh water and the extraordinary wildlife and natural resources we enjoy here. So thank you for including me in that. So, and thank you also for this. We're going to do a little experiment this time. So Lacey asked me, do you want to come back and talk again? And I said, oh my gosh, I've spoken in the COVID times on Zoom and maybe one other time. What the heck could I talk about anymore that I haven't already spoken of? And I said, you know what a fun thing is sometimes I will do this with students. I will just show up in a classroom and I say, there's a bunch of stuff that you've probably wondered. There's a lot of stuff you know, but there may be things you don't know about this thing we call climate change. Just ask me. I might not know completely the answer, but in my role and in my professional career, I've learned a lot of stuff about a lot of different aspects of this problem. I will tell you when I don't know something, and I'll tell you where I think the answer might lie, because I do know that. I often know where to go look for the answers. But we thought this could be fun. So we have no idea what will happen. But I'm going to trust you all have a few thoughts or questions you're willing to share. And we're going to do that. I'm going to actually share a few slides before we start, but a little bit of I'll offer up as we start some ground rules for that Ask Me Anything. We're going to make sure that everybody has a chance to ask a question. So as enthusiastic as you might be about one aspect of some component of climate change, we're going to make sure that no one person or one idea gets to dominate the conversation. And we'll need to be, because if we want people to ask their questions genuinely with open curiosity, we're going to keep an open mind when people do ask their questions. Does that sound like some good ground rules?
Yeah.
Okay. All right. Before we do that, though, I want to share a cool thing with you that I'm going around and talking to various people about across Minnesota, because it is a really extraordinary resource and something that's happening that I'd like for you to know about. And the reason why I want you to know about it is because in the subject of thinking about climate change, you might be wondering, what are people doing in this scientific community or in our scholarly community? We have a University of Minnesota. We have other universities too, but we have this one big public university. is supposed to be doing stuff that helps make life better in our state and in our world. And there are problems that need to get figured out, some problems that didn't even exist a few decades ago. So how are we working on those problems? This is just one example in the area of what we call adaptation. I'll tell you what I mean by adaptation. This is one activity. I'll tell you who funds it and who's part of it. And I want to show you a little bit about how we organize ourselves to address some new emerging scientific issues and questions. I'll share with you a little insight into what does it mean to, at the university, try to build a team of people who can work on a body of knowledge that we need in order to thrive in the future. Okay, so we call this the Midwest Climate Adaptation Science Center. It's, you can see, Midwest, that's not just Minnesota, that's for the whole region. It's an 8-state area, but we at the University of Minnesota, we are the home for the whole thing. So we have the responsibility, but also the privilege of thinking not only about what's happening in our own backyard, but providing leadership for the entire region and being connected to every other region around the country in leading on this issue. So here we are in Minnesota leading on climate adaptation. I have a clicker. Oh, look at this, a clicker. There's microphones, there's clickers, there's Zoom cameras. Okay, what do I mean by adaptation and adaptation science? So climate change adaptation is the side of climate change that is about living with the consequences of a changing climate. When we think about confronting climate change, we need to address it, to stop it, to limit the amount of changes that happen to our atmosphere and to our climate. And we also need to confront the reality that the climate is changing. And even if we stopped emitting greenhouse gases tomorrow, the climate would continue to change from the greenhouse gases and other modifications to our atmosphere into the future. So we are locked in already to a certain amount of what we might call global warming or climate change. And we're going to have to adjust to that. Our goal in adjusting to a changing climate is through our actions to reduce the consequences of it. Some consequences we can't reduce. We can't control that it is changing other than through greenhouse gas emissions reduction. But if we can learn about what those impacts are, we might be able to implement management strategies and other techniques to reduce those consequences. Think of it this, I like to think of this as sort of, if it helps to think of a sort of medical analogy, we need to, adaptation is about treating the symptoms of a disease, let's say, or an illness that you might have. It's not addressing, it might not be addressing the root cause, and we should be working on the root cause of a particular illness. But you know, addressing the symptoms is very, very, very important for quality of life in many cases. What is interesting about adaptation from a scientific point of view, so when I say adaptation science, I'm saying what is the research and the new knowledge that we need to do in order to figure out how to do adaptation well. Doing that science is fundamentally interdisciplinary. It's always practical. We're not doing this because we think it's intellectually interesting, though it is intellectually interesting. That's not the reason why we do it. We do it because we need the answers. And it's novel. Many of the things that we're talking about in ways that will adjust the way that we manage the world around us is not something we would otherwise be doing if we were not confronting climate change. That's a very important and very provocative notion for a lot of natural resource managers, a lot of ecologists. Some of the things that we're talking about fly in the face of convention because we haven't had to address this issue before. So it can be quite provocative. So in our Climate Adaptation Science Center, we are focused, we are a partnership between a collection of organizations, 5 of which are universities. I'll show you a picture of them in a moment. And the U.S. Geological Survey, USGS. The USGS is our federal partner and our financial supporter, though all of our universities are also financial contributors. We have 9 regions, so we are one of 9 regions formed relatively recently. Actually, it was Representative McCollum who was very influential in carving out the budget and demanding the creation of a specific Midwest region. Previously, we had been part of the Northeast. The mission of the Midwest Climate Adaptation Science Center is to deliver science. So our job is research, focus on fish, wildlife, water, land, and people, so that we can adapt to a changing climate. That means we're focused on actionable climate adaptation. We're looking for solutions, and we're specifically focused on natural and cultural resources. If you know something about the USGS, that makes sense, because the USGS is largely a scientific organization that exists to serve the needs of the Department of Interior and other federal agencies. So that's what we are, delivering science to help fish, wildlife, water, land, and people. Here are our 9 regions, including the Midwest region that was carved out from the Northeast. Each region has a USGS administration and colleagues there. It has a consortium, a collection of entities within the region to work with the USGS, and it has a host institution. So the University of Minnesota is the host institution in the Midwest. Let's see, the University of Arizona is the host institution in the Southwest, and the University of Washington is the host institution in the Northwest, and on and on. Who is the Midwest CASC? There are a collection of USGS staff. There's the host and the consortium investigators, a suite of researchers who are actually conducting work. There are researchers at the USGS as well. We have a community of practice, which are natural resource managers that we gather around asking science questions and helping us set a science agenda. A major component of the CASC is service to tribal communities and sovereign tribal nations. We have 2 regional liaisons to tribal communities. One of our consortium members is also a tribal natural resource management agency, and we have a tribal college in our consortium. There are students and fellows. We're trying to build the future workforce in natural resources that are climate ready, a federal advisory committee, and a suite of project partners. So it's a very complex integrated organization. We have a team at the University of Minnesota who leads this entity, including people at Lucinda Johnson. Actually, Lucinda, has she ever been here? Oh, she has. She's at University of Minnesota Duluth, and a collection of people at the University of Minnesota, including myself. We are partnered with other organizations. So at each of our partner institutions is another primary investigator. I'll show you a map of these folks as well. So each of these people is responsible for bringing their research universities or other entities to the party to participate in this research agenda. There's a suite of federal scientists that we work with. These people are all based at the University of Minnesota. We sit side by side with them. There's an advisory committee that helps the CASC, we call it CASC for short, helps us make sure that we're addressing the relevant questions. So these come from state, tribal, and federal agencies, and some nonprofits as well around our region. Here are the partner organizations. So we have 5 research universities, Wisconsin, Illinois, Indiana University, Michigan State, and Minnesota. We also have the Nature Conservancy, which gives us footprint in every single state. The Great Lakes Indian Fish and Wildlife Commission, Great Lakes Indian Fish and Wildlife Commission, GLFWIC we call it, and the College of Menominee Nation in what we now call Wisconsin, with the USGS. And I want to share with you, what do we work on? So what does it mean to do this research? So we're doing research, we're also building capacity, the ability to pursue adaptation. I have this picture here. This picture is important. And one thing I'd like you to understand about adaptation is that we have to figure out what the risks are. So in this picture, it is there's a section called, oh, does this have a pointer? Maybe, yes. Section called diagnose. This is the business of what will climate change do to our natural and cultural resources? Where do the vulnerabilities lie? What assets or properties are at risk? Then we say, okay, plan. What are we going to do about that? What are the strategies? How could we alter our forest management? How could we change our fishing seasons? How do we protect some of our resources from those changes? How could we manage differently? And then we implement. As scientists, we're not responsible for implementation, but we're responsible for evaluating implementation and figuring out whether or not it's effective, the strategies that we're implementing. Or in some cases, there will be side effects and negative consequences, and we have to back out of those situations and make adjustments and do differently. And that's why it's a cycle of continually figuring out what is necessary, what actions will work, testing them out, and updating them to make them better. That's what we do in our science. And we apply that across, let's do this. We apply that across a set of science priorities. I want to tell you what some of those science priorities are. Not surprisingly, our regional science priorities also are essentially a list of the issues that we are concerned about in our region with respect to climate change and natural resources. And so these science priorities go out as a call for research proposals across our researchers in our network. And we say, these are the things that we need to figure out. If you have a project that would address one of these scientific issues, send us a proposal. We evaluate those proposals, we fund certain teams, they go out, they do the research, and then that research comes back into conversation with our practitioners and the federal government for implementation. So we're always looking for projects in these areas. I'm going to go through each of them relatively quickly. The first major risk, and this is true of every region, but the manifestation of this risk is different in each of the regions, is changes in flood and drought, both increased flood and increased intensity and duration of drought. We call this an intensification of the hydrologic cycle. So more intense rainfall when it happens, and periods of time where rain is not occurring, or other precipitation. Heavy precipitation events, flooding, drought alter the condition, structure, services, and management of natural resources. So here are some example projects of things that are going on right now. We got a project at MSU looking at forest regeneration under different hydrologic regimes. We have a major question about changing precipitation is the shift from a forest ecosystem to a dryland ecosystem, the grassland ecosystem transformation. Urban impacts in urban environments and the urban forest. Novel terrestrial ecosystems. So as the climate changes, there will be unique compositions of species that come into contact with one another. So the sense of place, when you walk out into the woods and you say, I know that bird species, I know this plant species, they tend to be associated together. Under different climate regimes, you'll see different combinations of terrestrial ecosystems emerging. We need to figure out what those combinations will be, how those species interact with one another, and how we want to manage those systems. So shifts in vegetation and shifts in people alter the suitability for wildlife populations. So for example, myself, we have done some work on how changes to the Kankakee River watershed alter the availability of habitat for an endangered butterfly. Climate refugia for terrestrial vertebrates. We're trying to find places on the landscape that remain relatively constant in the face of climate change. Menominee Forest, those of you who might be familiar with the Menominee Nation, has this extraordinary managed forest, which is an amazing resource for the tribe. It's an amazing natural resource for our region and will need to be managed differently under climate change. Here's a big one. Maybe you experienced it a little bit recently. Loss of winter. Shortening of winter, changes in the amount and duration of wintertime precipitation has an extraordinary effects on natural resources. Altered snow patterns. A major project, in fact, we had a seminar the other day with a postdoctoral researcher talking about rain on snow events. that historically in the upper parts of our region, we didn't have very many what we call rain on snow events, or they would happen late in the winter, in the spring. And a rain on snow event has a very distinct hydrologic signal to it. Basically, that water, it's like rain on concrete, essentially. It just runs straight off. So looking at changing frequency of rain on snow events. Rain shifts of winter adapted species example project, bird distributions, looking at winter changes in winter survival, and projects looking at snow sensitive species. Impacts to fishing and hunting, specifically looking at sport fishing, also looking at culturally important tribal natural resources. So climate change influencing the abundance of invasive species, climate change altering the sensitivity of forest ecosystems to, say, deer and the abundance of deer. Altered hydrologic regimes, not only due to extreme flooding or changes in precipitation pattern, but having to do with also changes in temperature and flow. Examples of how you might manage rivers differently or potentially manipulate their flow to have an influence on, say, stream temperature. Including a lot of work in this on monomen, or the effects of climate and management strategies on wild rice. Adaptation, barriers, and opportunities. This is not just a topic for natural scientists. This is also a research topic for policy analysts and for anthropologists and sociologists. How are we going to change our governing practices, our ways of going about doing things, our norms, and the things that we teach people in forestry, for example? We're going to have different goals, different evaluation techniques, and there are a number of things that will potentially slow that down. And then a particular focus on the Laurentian Great Lakes. And this is one of the main reasons why the Midwest region was, in the end, couldn't hang together with the Northeast, because we got something really special and unique in the Midwest that needs its own science in the Laurentian Great Lakes. So that was my, did you know that in Minnesota we have a team of researchers working on this new topic? Those are my slides about that. If you wanted to know more about it, if you wanted to hear on a regular basis about research, about students, about young people who are building their careers around this discipline, we have a newsletter and anybody can sign up for it. You can also follow us in social media. If you really like science and are interested in hearing from firsthand from the researchers who are doing this work, they share that research in a virtual seminar series, which is the fourth Monday of every month. In our newsletter, you'll get information about that. You're all welcome to attend those. And I also put up here our website. So that's the Midwest Climate Adaptation Science Center. Now you know something like that exists in the world. Okay, let's change gears. Perfect, halfway through. That was the goal. I suppose if anybody, should we ask if anyone has any questions about the task first?
Any follow-up questions about the formal presentation portion of our time together?
You cannot invite a professor to come do anything, even if she says, let's do an Ask Me Anything. I have to bring my slides with me. I don't know what to do without them. Yes, sir, Eldon.
In our polarized political world, a lot of what you do is pure science.
Yep.
Is not accepted by one side of the aisle. How do you avoid being political when you can't help but be political?
Well, Elton, you're offering a little segue into what we could do in an Ask Me Anything. I'll say on this previous section, in this world of the Midwest cast, we have a lot less trouble because there is broad understanding that the climate is changing. At this point, it used to be you had to bring out your data to say, look, see the signal in the data, there is a change. Now people say, oh, I've seen it, I've experienced it, I know what it is. And I don't to engage with folks on adaptation, I don't need you to buy into any particular cause of that change. We are managing in the face of it. So in fact, for me personally, this notion of adaptation has been a good conversation starter about climate more broadly. It's a place where we can say we all want healthy forests, let's say. We all want to protect wild rice. I don't know. Yeah, well. We all care about the natural resource-based economy. So we're going to have to figure out what to do differently. And that has been a basis of some very fruitful and interesting conversations, which actually allows us to set our politics aside. Now, I'll broaden that out and I'll say the greatest disappointment for me professionally is the degree to which this issue has become politicized, climate change more generally. And I've been working on this since I was a graduate student in the mid-90s. So I've been working on climate for going on 30 years at this point. And it was not this political. There weren't a lot of people working on it when I started, in ecology at least. But it was not as political as it has become. We spent a lot of time talking to, different people had different ideas about what to do with the problem. As it has become political, it's first, for me personally, I'm not saying anyone else has to agree with this. It's just been disappointing because these are problems that need solutions, and they don't need just one type of ideological solution. They potentially benefit from all different kinds of solutions. So I wish that we had broader participation in the problem solving from a wider set of political ideologies, but we're getting there. We're getting there.
Question from Mr. Phil, who donated some upgrades to our technology today. Thank you very much.
Wow, thank you.
You mentioned wild rice.
Yes.
I've got a friend of mine that's outside the Duluth area,
Yes.
and there's a group of people in that area that are concerned about the, I believe it's on tribal land from what I've been told, and the wild rice is a food source.
Yes.
For geese and whatever else.
Yes.
And the people down there, I believe, this is one of their incomes from that wild rice.
Yes.
And it's down the St. Louis River.
Yep.
Do you have any input on that as far as what is being done, or what are some of the things that can be done to eliminate this problem?
Yes, there are a whole suite of issues that are relevant to the health of Monoman and wild rice beds. My particular, through this work, our particular interest is what the climate variables, how climate affects it. So for those, many of you probably know this, wild rice is an annual plant. So every year it has to reseed itself. That makes it fairly dynamic. It can come, the good side of it is it can flourish when the conditions are right, but it can also very quickly decline if the conditions are not right. And those changes, wild rice also grows at certain water depths on certain types of soil substrates. So changes, for example, in the intensity of hydrologic extremes, those heavy rainfall events, the total amount of rainfall, the amount of precipitation that we have stored as snow that runs off in the spring, that all affects hydrologic dynamics, and that all potentially can affect wild rice. So we have a bunch of projects, for example, people looking at how does vegetation on the broader landscape, the broader watershed, affect the flow of that water into the waterway, which would affect wild rice. Another possibility is changing distribution of waterfowl and other species you talk about that feed on rice. So there could be new organisms coming into our area. So we are tending to work on what the climate aspects are. I would direct you to the Great Lakes Indian Fish and Wildlife Commission, the GLFWC. They are engaged in every aspect of wild rice natural resource management, including water quality considerations and access, ownership, things like this that are other parts of the puzzle that we tend not to work on so much.
Mr. Hudson.
Hello.
Perhaps a bit of a softball. Can you tell people how finding a German sister city for your city helps to mitigate the harms of climate change? And how I&E might be involved with such a radical idea?
Okay, so I'm going to use this softball. I'm going to step back from the plate for a second first. When we think about things that I made up this slide, like what might we talk about next? And I said, okay, well, what are some of the sources of climate change globally in Minnesota? How do people know anything about this? And is it possible that they're wrong? What are the impacts in our region? In this one, Hudson, we tossed this one up there. Is there a positive vision about climate change? Is this only a depressing thing where we all need to climb back into our, go back to the way life was before with no creature comforts or something like this? Is there a positive vision out there? I put some others up here about actions that individuals can take in examples of thriving clean energy economies. So Hudson is referencing, and some of you, I understand, may have heard a presentation on Sunday, day before yesterday, by Troy Goodnow at the University of Minnesota Morris, where Morris has been pursuing at the community scale something they call the Morris model. Troy was there and he can explain it better, but my understanding is the Morris model started something like this. There were some people at the diner who are involved in various parts of the Morris local economy. They sat down and they said, we should do some projects together. Let's do some cool stuff. And they made a list, a long list. And ever since then, they've just been working on crossing things off on the list. Things like we could build a battery storage facility that would power the school and the hospital and the university. We could change some operations in city government, a variety of different approaches. And they've now been working on this for a while, 6, 7, 8 years, and they've crossed a lot of things off on their list. And now they've become a model community for other people to benefit from or learn from. In fact, in addition to the fact that they had motivated people who sat down and made a list, they had friends. And they had friends in this town called Saarbrück in North Rhine-Westphalia. If you're familiar with Germany, this is sort of the industrial part of Western Germany. And through the Institute on the Environment, we had a long-standing collaboration with the German government at our state level and their federal level. And we developed this Sister City program where we found that a number of analogs in Germany and towns in Minnesota. And one of them was Morris, right when they were getting started on their Morris model. And Morris and Saarbrück are very close. They visit one another multiple times per year. I was at an award ceremony one time where their partnership won an award and they were all in tears, hugging and going on. They've really supported one another. Saarbrück would be an example of a model community in Germany. Exactly the same thing. It's a relatively rural, small town. A bunch of people got together with some leaders in city government and they just said, what could we do? We want to do some stuff. And they started doing it. And then they got momentum. Once they started doing some stuff, they got some more stuff. And then they got some outside money. And then other people were interested. And it just grew from there. So we have a suite of partner cities across Minnesota. And we were talking, like, could there be a sister city for Ely through this program? I'd be happy to talk about that some more. I think there could be. And you really got to commit to making setting your ambitions for your own community. And then you got to commit to the friendship and the partnership to hold hands through that journey. Because in the case of both Morris and Saarbrück, there are problems that happen, lack of resources, setbacks, and they help each other through it, like friends do.
Hi, Jessica. Thank you very much for speaking here today. In your last bullet, You put resilience
Yeah, and
and
adaptation.
slash adaptation, and I want to ask you about resilience and how your work relates to that.
Okay.
So when I think about resilience, I think about the Biden administration's 30 by 30 goal,
Yep,
protecting 30% of the land and water in the United States by 2030.
yep,
And that process ensures that if all goes well, locking in ecological integrity of large landscapes.
mm-hmm,
Large landscapes which tend to be more resilient because they're large landscapes. They're
Mhm.
large in size, they're migratory routes. They allow space for adaptation in its natural course. It's
Mhm.
really nature helping us adapt to a changing climate and a biodiversity extinction. So I'd like to hear a little bit about how the new Midwest
Mhm.
Center adaptation work correlates
Mhm.
with the resilience efforts.
Great. So thank you, Becky. That's a terrific question. So I put these, I said, what is the relationship or difference between, and I put together resilience and adaptation, and I contrast it with what I called mitigation or decarbonization. This is what I was saying earlier, that we both have to confront the root cause of climate change, which is greenhouse gas emissions. We put that in the decarbonization or mitigation camp. Renewable energy, changes in agricultural practices. And then on this side, the resilience adaptation is about living with the consequences of climate change. Now, there's lots of debate about vocab, but my own sense of the vocab, I think, is the right one. And I think of resilience as a form of adaptation. So adaptation is, for me, it is about how will we adjust? What will we do? How will we manage our landscapes? How will we recognize that the climate is changing and take steps to adjust to that changing condition? And one of the things that we might do is to what we call promote resilience, which is we might not necessarily go in and say, change the tree composition of a forest, or change our timber rotation time, or alter the flow of a river to change its depth and its temperature profile. Those are all those things I just rattled off are very action oriented. They change the management technique. But one management technique is to manage the system as a whole for its resilience. As you say, allowing nature the space to evolve or adjust in the ways that it can. And knowing what we can also step back and kind of juice the system a little bit to enhance that resilience. One strategy for enhancing resilience is total area and the connectivity of that area. In a larger area, there are more of these climate refugia, little pockets in the landscape that are doing distinctive different things, that have different climatic features that hold on to certain species or certain ecosystem functions. In a larger landscape, there's more connectivity, more ability for species that are trying to move through the landscape as they adjust to climate change to move unimpeded by, say, human development. Larger areas of land can have natural features that might even change under climate change, like fire, but they might be, say, protected from human risks, or could burn in a mosaic in a larger area. So there are a bunch of properties of larger protected areas that make them more resilient. There are other ways to enhance resilience, not only in large land areas, other things that we can do. And those two are related. There are some adaptation actions that we can take to enhance resilience. Like thinking about forest stand diversity, for example, makes forest systems more naturally resilient. And last thing I'll say about that, and I'm saying quite a lot, this 30 by 30 initiative, we in the US, we attribute it to the Biden administration. The Biden administration has embraced this. In the Biden administration, it's called the America the Beautiful program, but it's actually it's a global goal. It comes out of the UN negotiations. Back in 1992, at the United Nations Earth Summit, we set out a number of different goals. One of them was to address climate change as a global community. That is something we call the UNFCCC, the UN Framework Convention on Climate Change, came out of the Rio Earth Summit. And we continue to gather as a global community every year, making policy progress on climate change. Another one is called the Convention on Biological Diversity. And we gather together every year thinking about what do we do to stop and slow the biodiversity crisis. The United States is not a formal signatory to the Convention on Biological Diversity, but we participate in that dialogue. And the notion of 30 by 30 has been embraced by that Convention on Biological Diversity. And though not a signatory, the United States, under its current administration, has embraced the idea and is advancing it within policy within the United States. And that intersection of climate and biodiversity is an interesting and important one.
Here you go, Mark. Thanks, Jessica, and thanks for being here. We know that you know the area reasonably well, having been up here for some time. We wonder what specific examples you might have in your mind about what we and the area should be doing, thinking about the next 10 or maybe 20 years.
Yeah, so Barb sent me an email telling me, giving me heads up, I'm going to ask you a question about what the future could look like. So I've been thinking about it a little bit. You know, because oftentimes when we talk about tackling climate change, in fact, I'll show you, you know, I put it in here a whole bunch of slides, like things we could talk about, you know, climate models, but oftentimes we see pictures like this, or I'm just going to show like this, you know, or I have a picture of, oh my gosh, don't look at that one. Oh, it's too far in the future. I'm not going to be able to do this the way I want to. Oh, never mind. Never mind. I was going to show you a picture of greenhouse gas emissions by source. There's like a pie chart in here. Oh my gosh, now I'm committed. Okay, like this, where we've been the entire United States and we say it's transportation, it's industry, it's electricity production. And then we often start our conversations about what the future could be like by going into each one of these sources and sort of thinking about, okay, well, what's our answer for transportation? Well, we're gonna need some electric vehicles. What's our electricity? Well, we're gonna have distributed solar. But the truth is that what this looks like in every community and what is good for that community and a source of economic development is different in every particular situation. We all need to be rowing in the same direction, if you will. But what is beneficial is very distinct, and what assets you have. This is what's powerful about the partnership in this climate smart municipalities and between Morris and Zarbeck. They have things in common. Therefore, they have common potential solutions. So what is potentially ways in which Ely can contribute and Ely benefit, right? It's not just about how does this community do its part to stop global warming. It's about the fact that the economy is changing. And how do you position yourself as a community to take advantage of the economic opportunities in the new world that is coming? And so Zarbeck and Morris have some things in common. And oftentimes, I think we will look around the world and even in the United States, we look to urban areas. A lot of people live in urban areas. There are a lot of assets and capabilities in urban areas, and there are very specific urban solutions to this challenge. They are very, very different in rural communities. They're also very different in Ely than they are, say, in Morris. Very different. Morris is an agricultural community. It's in Western Minnesota. It's got a lot of wind power possibility. So I think here, well, I guess I'll tell a little story about Zarbeck. What are they doing in Zarbeck? So in Zarbeck, it's all started with, they had an old asset. They had a munitions depot. So they had old military stuff that wasn't being used. But it was owned in some way, it was sort of owned by the community. It was a common asset. It was a public asset. So it was available for redevelopment. And they redeveloped it into a solar and wind facility. They put in a anaerobic digester because it's an agricultural community, and basically became a new energy powerhouse for the town. In addition, there was a lot of wind development that was going on, and a lot of farmers were leasing their land to wind production that was basically going to town, to the city, being produced. So they're exporting power, large amounts of power. And one thing they came up with is like, well, could our town tap into a small amount of that power for some local purposes? They also built a microgrid. They built a battery storage facility. They had very specific policy reason for doing that. Out of some of that excess electricity that was available to them, they pursued some new light manufacturing, which generated income through high value products. So looking at those kinds of towns and thinking about that, thinking about where could an energy source come from. I do think for Ely, thinking about diversifying, so they diversified their economy. So they were in the power production business, power storage business. They were harvesting power for light industry, and they were a farming community, when before they'd been pretty much just farming community. Thinking also about how a town like Ely produces high value goods. I know that natural resource extraction economies are important, but you take a lot of that value chain gets added somewhere else. How can you capture, in this new economy, there's an opportunity to capture more of that value production locally, which generates more economic opportunity. And then of course we talk a lot about tourism and the value of your natural community, which has its own, it's not a source of greenhouse gas emissions, but it is a sink. So it contributes to the global community and the global greenhouse reduction goals by sucking up carbon and providing that kind of resilience that Becky was talking about.
Mr. Ben.
I'm curious, this may be not as locally applicable, more of the Midwest. I'm wondering what insights you have about agricultural resiliency. As far as my knowledge, our industrial agricultural system is unsustainable, but also non-resilient to climate change. So I was wondering if there's research or what insight you have.
So in ag, there are many different issues in ag. Firstly, well, this is carbon dioxide emissions. If we had other greenhouse gases, so I have another slide that says, this is what I tell, well, my grandmother is long since deceased, but I say, if I were telling my grandmother about climate change, I would tell her it's 3 gases, 3 sectors in the United States. That's it. It's not complicated. It's 3 gases, 3 sectors. CO2, methane, and nitrous oxide are the 3 most important greenhouse gases. There are some other ones, yeah, but they're kind of just rounding error, more or less. 3 sectors: agriculture, electricity, production, being 2 of them. Let's talk about agriculture. So agriculture is a source of greenhouse gas emissions. And so when we talk about it being unsustainable, we're saying it cannot continue to emit, and you probably want to know what's the third one. Transportation, agriculture, and electricity generation are responsible for a lot in the United States. If we were outside the United States, we talk about deforestation of it. So in the agriculture sector, we need to be sustainable. It needs to stop being a net emitter of greenhouse gas. And there are a variety of practices that potentially can do that. And that's a whole conversation. Perennialization being a really popular and intriguing idea that we're working on in Minnesota, including the development of perennial crops. I think that's very intriguing and interesting and part of the sort of economic innovation possibilities for our region. But the flip side of being a source of greenhouse gases, ag could also be a sink of greenhouse gases if it wanted to be, or they're the right incentives. And that is because you can store carbon in soils. Soils that have carbon in them also tend to be healthier. And so they can, when managed correctly, lead to higher productivity as well. We don't currently have any incentives beyond the productivity value. We don't have a lot of incentive to maintain, really healthy soils and to store carbon in soil. But that could change very readily if there was something like a carbon price or payments for carbon sequestration. And that would incentivize farmers to say, not only can I produce food, but I can contribute to the economy by sucking up carbon and be compensated. It becomes a crop in and of itself. The third thing we talk about in agriculture is the potential for it to be part of renewable energy generation. Oftentimes we talk about ethanol or biofuels, where ag is already part in Minnesota of fuel production. There's lots of interesting things to say about that. But placing wind and solar in agricultural communities and diversifying the economy so that farmers become not only using photosynthesis to make energy, but also making electrons to make energy is pretty darn provocative. Also something in Europe that has been widely explored is integrating renewable energy production into agricultural communities. And that can have a large influence on economic diversification and sort of stabilizing community revenue as well.
Sure. There you go.
Hi, I'm Betsy,
Okay.
and you just actually brought up whatever part of it
Yeah.
I was leading into. I've been kind of following a soil scientist, and I've been very intrigued with her work. Her name is Dr. Lydia Jennings.
Okay.
And she's from Arizona, where she worked on remediating soils. And I was wondering, have you got a soil component in your research?
You're going to love the reason why I'm laughing. Do we have a soil components in our research? Absolutely. And one of the values of not only agricultural communities, right, but natural communities, ecosystem services, sequestering carbon and storing carbon has extraordinary potential, in some cases more than agriculture. And there are a whole bunch of soil scientists working on that. Also, there are a lot of soil people working on peatlands and other kinds of very specialized ecosystems that we have here that are both sensitive to climate change or potentially big contributors to climate change. But I laugh because we love working with the federal government. We love our USGS colleagues. But when we want to talk about crops, we are told, nope, that is not the USGS, that is USDA. And so in the federal system, there are some silos about who's working on what, which are going to need to be overcome because a lot of adaptations, in fact, this is true even of the sort of future economy thing. The answer to the future visioning is what we would call systems coupling. It's how you think about, we're going to do one thing. How could that one thing be connected to 4 other things? Instead of saying, this is a farm, it only makes food. And this is a power plant, and it only makes power. And they're managed by different agencies with different regulations. We need to think about how those things can be interwoven and complementary to one another. It's a very important thing under climate change. And some of that is going to require some innovation in our governance strategies.
Innovation would be Lydia Jennings.
Okay.
Is also a tribal person. And so you could bring her
Yes.
in and soil scientists to that.
Yes. Soils don't really care so much whether they're in one silo or another silo.
I think we're gonna need another two-tier
Okay.
presentation on systems coupling, but for now,
Yes.
Claudia has a question.
Yeah, hi, I know the time is limited here, but thank you. I really appreciate what you're saying. I just wanted to contribute to the conversation.
Please.
I work for AmeriCorps and I'm part of the Community Forestry Initiative. And now my role has changed now with the new Biden administration as a climate project coordinator. And I just wanted to connect with the community because I know there's so many wonderful people here that are so dynamic. I'm so impressed working here. And my goal really is more in working in just with the community. I think my concern is that, and I don't know if other people relate to this, but there's so many buzzwords. Climate change, climate grief, this and that. And it's a little bit intimidating for the general public to really understand. It's like, oh yeah, we get it, we hear about it all the time. So my master's degree is in advocacy, and so my job, and I want to get your opinion on this too, is to be the one that translates what I'm hearing and what I'm learning and what I'm trained with what I do to the general public on an everyday level. And so that's what I'm doing right now is as I'm doing my work, I'm just talking to people in the community. I'm asking what they think. I'm just kind of like digging. And so that is, because we're trained more in storytelling. That's a really big issue, big factor with what I'm trained. I just am concerned about that. There's
Mhm.
just a lot of buzzwords.
Yep.
And we need to really do the groundwork to work with everyday people. And so we can interpret what we hear so that we can really take and make an active effort to do something. And also with my training, with the Biden administration, what they're having us do, for me going forward, is to work individually with a community. They have not defined explicitly what each community does,
Yeah.
you know, but what is the community, this community need?
Yeah.
It's like you said, it's so different for every community member. So, or, anybody in this community.
Yeah. There are top-down principles, things that we are seeking to do across many cases, like reducing tons of CO2 being emitted. But how that's manifest is going to be different in every place. And that grassroots approach is really important. I guess in addition to what you expressed, and it sounds like you probably do this, on the subject of siloing and in being a community and addressing things that are in a systematic way, I assume you're out talking to people saying what you're doing, but you're interested in completely different sectors of what other people are doing and trying to find ways that they could be connected to one another. Because a lot of that innovation and creativity and discovering new ways of doing is actually at those seams and those areas of connectivity that we haven't connected before. On the subject of complexity and buzzwords and vocab, and do you need to be like in the club to understand what the heck is going on? So this is why I make slides like this. I say it isn't complicated. 3 gases, 3 sectors. So my personal approach is to often say that, like, I'm in that club. I go over there every day, and I'm up to here in all of the buzzwords. And but I can come back out and I can say it is complicated. Like, there's a lot of complicated stuff, but the basics and the creativity that is needed is not complicated. And so we can have that duality. I can be in the back room working with our, pretty darn sophisticated mathematical models and still come out and talk about the fundamentals of what is in that model. It's not, and I think we need to have both of those things. I guess one mistake that we have made in academia is we made it seem like you have to be an expert in order to have any credibility. I don't believe that. But I am an expert, so I want to show up as one. And so I do sometimes talk about vocab to sort of demystify these ideas. But I don't think that, that's just the way that I communicate, and lots of other people need to be part of that communication too. One time, an old man, oh my gosh, if she heard me say old mentor, she would die. A mentor of mine said that it's kind of like going to a restaurant and you're seated at the table. There's a menu. The information you need is on the menu. You know what you like. You're interacting with the waiter. And there's a bunch of people back in there in the kitchen, and they are doing some complicated stuff to make what comes out of the kitchen good and interesting. You don't need to know all that stuff that's going on in the kitchen in order to be a well-informed, have a good experience, express your choices, get what you want, know that that's a soup and that's an entree, and it's all just fine. And that maybe we've made an error in sometimes saying, come back in the kitchen and we'll show you all the details. And if you don't understand everything that's going on in the kitchen, then you're out of luck. And that's actually not true. We can have both. I don't know if that makes any sense or resonates with you, but.
Makes a lot of sense to me. That's a cool analogy.
I was just going to say that's a wonderful example. Yeah, I've noticed that three of the last 4 winters have been quite mild.
Yeah.
And we're not seeing -50 and -60 below lately. And I'm wondering if that's an indication of climate change, or do you need more time than that?
Oh, this is a great, okay. I know we're past time, but this is a terrific question. Another thing that happens in the political discussion about climate change is that if we don't know everything, we act like we don't know anything. And it's possible for us to know quite a lot and not know everything. So I like to say, when I said to Elton, my greatest disappointment is that we have so much controversy over the basics. I wish that we could spend our time arguing about what to do, not about whether or not it's real. But I also wish that people understood that there are fierce arguments in climate science, fierce ones. They just aren't about whether or not CO2 is a greenhouse gas. But one active area of research is that polar vortex. It's not very well understood at the moment whether those super duper cold temperatures that we get, is that a climate change related phenomenon or not? There are some models that suggest it is, that a global warming phenomena leads to this sort of instability of this circumpolar pattern that establishes in the winter in the northern hemisphere, and the how stable that is. It has historically been quite stable, and lately it's been getting kind of loopy. And so these loops come down, and we basically get Arctic air, as if it wasn't cold enough already. Here, there's some evidence that suggests that in a warmer world, you could get that more loop-de-loo phenomena, and we would get more of those cold snaps. But that is an unresolved scientific question right now. That's a cool thing. I think that's a cool thing to think about. We need more data, we need better models, but we can still put on the table that it's a possibility that those cold snaps could actually be related to global warming. And that kind of can blow your mind a little bit. What would be other areas of active research? Intensity of hurricanes in the Gulf of Mexico. We know that warmer waters associated with warmer global average temperatures leads to more intense hurricanes. But there are these counteracting forces that you can get more intense more intense winds in the upper atmosphere, which has the phenomena that when a hurricane is forming, these high winds can kind of cut it off and undermine the power of a storm. So we're still sort of learning what's more important, the elevated sea surface temperatures and driving the hurricane, or this undermining phenomena in the high atmosphere. It's an ongoing question. The data actually suggests that the intensity of hurricanes is increasing, but we're still studying these phenomena. So I wish that we could be really clear on some things and allow other things to still be open to discovery.
We have
Okay.
discovered a lot
The end.
here today. Oh my gosh, such intelligence. We are so
Yes.
grateful to you for being as articulate as you are and sharing your decades of research with us. Round of applause for Jessica Hellmann.
Yeah.